We are in section 5.4 day 1, and I want to show you one more proof that for the day that has to do with the power reducing formulas. Now, I mentioned at the beginning of this section that with power reducing and half angle formulas, you should avoid using them at all costs unless it actually says to use it in the problem. And so in this case, since the directions say to use it, let's use it. Here are the power reducing identities down here, so we're going to use one of those power reducing identities at some point in the problem. We'll just have to see what it is as we go along here. Now we want to prove that sine cubed is equal to all of this mess right here. Now again, since we are talking about formulas like the last time, I'm actually going to use the simpler side, or the side that looks simpler first, so that we can get all of this stuff here. Now you'll notice that we need to get it down to sine and cosine, not sine cubed or even sine squared. So what we have to do is try to start breaking this down. We're going to use power reducing for that very purpose, but first of all, in order to do power reducing, we need to have it as squared instead of cubed. So let's split this up just one step by saying sine squared times sine. That will at least get us down to a point where now we can take this piece and use a power reducing formula for it. That'll be next. So sine squared. It's a u in here, but we have an x here. So if we've got sine squared, we're going to replace this with 1 minus cosine of 2x over 2, just, due to the fact that that's what the power reducing identity is. And then multiply by sine of x, as that is still sitting there. So now, if we want to get it into the form that we see up here, you'll notice that we've got the 1/2 and we've got everything else not in fractions. So what I'm going to do with this next step, and this is just, thinking ahead, seeing that we've got the 1/2 here, is looks like we have to split up this fraction. So I'm going to split it up, leave it in parentheses though, and I'm going to say that's 1/2 minus, and this is cosine of 2x over 2. Well, if it's divided by 2, it's also the same thing as multiplied by 1/2. And so I'm just doing this in order to get it closer to what my right-hand side looks like. And then the sine is still sitting out there in front. Last step in this process is just going to be to distribute the sine to each one of those, make it look just like what we see up here, this whole right-hand side. And so sine times 1/2, that's 1/2 sine. And then we distribute it into here. We want the minus 1/2 sine times cosine 2x, and we'll find that that is the right-hand side we were looking for here. Again, these proofs that, you're probably wondering, why are we doing these proofs? It's mainly to get really comfortable with manipulating these different identities, because then when we actually have problems like solving equations or evaluating certain trig ratios, that we can actually use that information to our benefit. Proofs in and of themselves don't have a lot of practical use, but if you can do a proof, then you're probably doing really well with all the different maneuvers that can be done using the identities.